Hello, everyone. Thank you for having me as a speaker today, and thank you for being present here as well. I'll be talking about GraphQL in .NET Core today. I'm Poornima Nayar. I'm a freelance .NET developer. I'm not far away from Reading. I'm based in Langley, UK. I'm a Microsoft MVP for developer technologies, and my day-to-day job is far away from GraphQL and Blazor. It's all to do with Umbraco, which is a .NET-based CMS, open source CMS, and I've been their MVP for the past 2 years as well. Non-work me, you'll find me spending a lot of time with my little girl. I read mainly fiction. I can read a lot. That's my way to unwind. And I'm also a student learning Carnatic music vocals. And that's my Twitter handle, should you wish to connect with me. Straight into the topic. When we think about GraphQL, it comes across as one of the cool kids on the block. So I'd put it in my talk summary as well. So essentially, GraphQL is a syntax. It's a syntax to ask things from your API. It's a query language, so that is why I put down the query language for APIs, but it is supported by a runtime that supports or can decipher this query, parse it, understand it, and give back what you asked for. And all this is based on your existing data. GraphQL doesn't concern itself with where your data is stored. It only needs an address to fetch the data from, because GraphQL is more about giving the information that you need in the shape that you asked for. As a at the simplest definition, what you can talk about GraphQL is it's all about having types and then asking for specific fields on those types. So if you imagine a type as a C# class, you're asking for specific properties on those types. There is no way you can say that, hey, get me all, say, if you have a course object, get me all the course object. That's not possible with GraphQL. You specifically have to ask for what you need. GraphQL is a specification. So there's a lot of implementations of GraphQL across various different programming languages, and all those implementations try to make use of GraphQL as a blueprint or a contract and tries to fulfill it. Often, we can visualize data and the relationship between the various objects as a data graph, and GraphQL helps you extract parts of it, hence the name GraphQL. And why did GraphQL exist in first place? So back in 2012, when Facebook came up with their first mobile application, it was banned. It was completely banned for the way it was draining out the battery and the network usage of the mobile devices. So it was something around the news feed, if I correctly remember. So some kind of a scenario like this was happening. First, it would try and understand the logged in user. For that user, it might try to reach out to an events endpoint, getting all the events that could be suggested to the user, get a list of friend suggestions, get a list of friends' birthdays, and for each of these endpoints, then further get more details about each of the event or suggested friends or the friends for their birthdays. So it was like a pyramid of calls happening, a whirlpool of issues, thousands and thousands of REST API calls happening, and finally, what the end result is the end user getting deprived of the battery life as well as network bandwidth on their mobile devices. What was happening under the scenes were overfetching, which means that at any point of time, the app was getting a lot more data than it actually needs and then discarding the rest. So for example, I might only want a few events and their names and date and times, but in reality, I'm getting every possible event, every possible detail about an event. So with friend suggestions, so with friend birthdays. And underfetching, that's another issue which goes back hand to hand with overfetching. And what happens is at no point an app has all the information that it needs. For example, there is no way for the app to get events, friend suggestions, and friend birthdays in a single call, which means it has to make more API calls, which means more overfetching. So it goes hand in hand. And there's the N+1 problem, which means that to get information about N objects, you're effectively making N+1 calls. So the engineers at Facebook, they rethought their strategy and they came up with GraphQL as a solution. And what GraphQL is a single but smart endpoint, and it takes in queries and then it builds the data output. And what clients or the consuming apps can do is specify the shape of the data that they need, and the server responds back with the same exact data graph. So if you look at the example I have here, on the left is my GraphQL query. I'm asking for a course of ID 1045, asking for some fields and related information. And the information I get back is JSON, and it is a mirror of the query. So the query is JSON-ish, but what I get back is JSON. But the most important thing it's predictable. It's an exact mirror of the query that I asked for. Not only that, I'm specifically asking for the fields that I need: ID, credits, title, and something like enrollments, which could be in a normalized data world in separate tables. It's related information. But I can gather all that in a single call to the endpoint. That is the most important thing here. And GraphQL gets you back exactly what you asked for, nothing more, and tries for nothing less either. So if in terms of analogy, we are presenting this, a GraphQL is like a smart person that tells you, hey, give me the address of the pizza shop and tell me what you need. I can get that for you. Similarly, I can run to the grocers, but tell me where the grocers are and what you need, and I can get that for you. So where the address of the place and what to get is the most important things here. While as with REST, it would be like you running to each of these places one after the other, and then losing out or getting more things that you need. So if we are to talk about some of the features of GraphQL, let's start by saying that it is strongly typed. At the heart of GraphQL is something called schema, which we will see about in a short amount of time. So there's a strongly typed schema at the heart of the GraphQL API, any GraphQL API. GraphQL is a specification, as I said before. It is introspective. Now, this is quite an interesting feature because a GraphQL API, a service, can query itself and understand more about itself. And this has given rise to many tools and IDEs, browser-based IDEs, which helps you testing and have up-to-date documentation either. And that's another set of tools that have come out, self-documenting tools for APIs. It's something a bit like Swagger, but we'll have a look at that a bit later on again. GraphQL respects the hierarchical object relationships in your data, and what you get back from a GraphQL service is JSON response, and it exactly mirrors the query. So if you have a query to say get the data or insert or update or delete the data, what you get back from the query, from the post operation or the operation that you make to the service actually mirrors the query that you pass in. GraphQL is an application layer, so it's a layer which exists in between your data as well as the client consuming app. As I said earlier, it doesn't concern itself with where the data resides. It only needs an address. And so it can be a third-party REST API service, or it can even be another GraphQL service that you're dealing with as the place to fetch the data from. It is version free, so one of the biggest headaches with REST is gotten rid of. With GraphQL, because the client is in control of what it asks for, if you keep adding features to a GraphQL service, it is business as usual for the client because the client doesn't know about it until they start consuming it. So it is loosely coupled, and these two, the client and the server apps, can kind of iterate and continue developing at their own pace. The only time when you can actually break that relationship between the client and the service is if you remove something that is being used, obviously, or if you change the nullability. But there are, again, ways to overcome it by marking fields as deprecated, and then that can be then passed on to the client via the testing tools. Finally, GraphQL is transport layer agnostic. So while HTTP is the most common kind of protocol used, it works over TCP, gRPC, and any other protocol that you can think of, basically. There are some big names in the GraphQL world these days. Facebook was the obvious inventor of GraphQL. GitHub has a V4 API completely on GraphQL. Shopify, PayPal, some of the other big names in the GraphQL scene. So now let's start looking at the type system in GraphQL. So GraphQL, as I said, is a specification. And at the heart of GraphQL, any GraphQL service is something called schema. Because GraphQL is a specification, we need a language agnostic way to talk about GraphQL. And GraphQL SDL helps you talk about the GraphQL schema. And a schema is what resides on the server and is at the heart of the API. And a schema is made up of types. So the first type is the object types, which is a representation of the object that you can ask for from your API. So in my demo today, you will have a course object and a student object. So these are object types, and you can ask for the information about them. You can change details about them. So they are all object types. Then you have your operation types. Now, this is where it starts getting exciting. Queries, this is for reading data. So it's a kind of confusing terminology because what you send into your service is a GraphQL query, and the operation type is also called query. I think it makes sense because GraphQL was primarily invented as the first point to read data in Facebook. So queries is one of the first operation types. This is used to get data. Then we have mutations to insert, update, or delete data. And then you have subscriptions for pushed updates. So all these makes up the types. So when a call happens from the client to the service, it is validated and executed against the schema. The schema, again, doesn't concern itself with fetching the data. It only needs an address. It's a point of validating what you send in. It is implementation agnostic, basically. And types are made up of fields, be it your operation types or your object types, they are made up of fields. Each field must have a name, which is the name used for sending a GraphQL query to the service. It must have a type, which can be a scalar or a complex type, which is the concrete type it resolves to. And finally, the resolvers. This tells the field how to get the data or where to get the data from and how to convert that field into a concrete data. And this is how a type will look like in SDL. So this is a custom object type called student type. That's the student type. That's the name of the type. And then it has fields, and it has a scalar or a complex type. Out of the box, GraphQL only supports 5 scalars: integer, float, string, Boolean, and ID for unique identifiers. If you're thinking about date time, that is something that you have to implement in your own GraphQL implementation. But packages like GraphQL.net, which I'll be demoing today, Hot Chocolate, or many other implementations across many programming languages, they come up with custom scalars to give that extra help to the developers. So in the package that I'm demoing today, we have a lot more scalars than these. And if you want, you can always, by all means, write your own scalars. We can have enumeration types as the return or the concrete type of a field. That's again possible. It's very similar to C# enums. You can have non-nullable fields. So this is the syntax for marking a non-nullable field. So if the data, the type of the field is followed by an exclamation mark, that means it is a non-nullable field. And you can even have lists. So in my example, the enrollments is a list of enrollment type. Enrollment type is, again, probably an object type or even an enum. And the syntax for list is the square brackets. So in my demo today, I have this database, which is based off the first few tutorials of the EF Core MS Docs. So we have a course table and a student table and an enrollment table, which ties up the information between the course and the student. There's a one-to-many relationship between student and enrollment and one-to-many between course and enrollment. And we'll try to build a service on top of this data, a GraphQL service, and we'll see how it is consumed and presented in a Blazor application. So thinking about GraphQL in .NET Core, there are 2 server packages available for building your service. The first one is GraphQL.net, which I'm going to be demoing today. It's been a package out there for some time. Even though the development went down on it, I think during some point of time, it is back up and running. There's active development going on and a community around it as well. And the next one is hot chocolate. It's one of the shining stars out there with GraphQL in .NET. Again, both are open source, and hot chocolate has, again, a very active community and even a Slack channel for the community with people helping each other. So both of these are open source. If you can help out in any manner, like contributing to the code or documentation, feel free. Always nice to help out. So this is on the server to create your service. And then you have two client-side packages. By all means, you can use HTTP client in .NET Core to query your GraphQL API. But both of these packages comes with their own clients to support querying. It gives you that extra help. So GraphQL.NET Client is from the house of GraphQL.NET, and Strawberry Shake is from the house of Hot Chocolate, Chili Cream. And we also have IDEs, primarily browser-based, like GraphQL Playground. Most of these are browser-based, while Insomnia and Banana Cake Pop, which is again from the house of Chili Cream, Hot Chocolate, and Strawberry Shake, these are desktop-based applications. But I think a browser-based version of Banana Cake Pop is also in the making. And these IDs are super. If you have used Swagger in the ASP.NET or ASP.NET Core Web APIs, this will come across to you as something very similar. Uh, it helps in syntax highlighting, IntelliSense, testing your queries, schema introspection. And I think personally, my favorite feature of these IDs is the up-to-date documentation. Because GraphQL is introspective, it makes use of that feature to create up-to-date documentation from your API. Let's get started. So let's first talk about the server side. I have started off with an ASP.NET Core Web API empty solution, and I've installed the Transports ASP.NET Core package. So that installs all the middleware for HTTP and also installs GraphQL as a dependency. GraphQL is the actual implementation of GraphQL in .NET, while the Transports ASP.NET Core gives you the additional help for HTTP. And because everything is based off JSON, we also need ways to understand JSON, which is why I've installed the system text JSON package in here. There's also a Newtonsoft JSON package available, so feel free to use that. And I've also set up 2 playgrounds for demo purposes. So let's have a quick look at the setup. So this is my solution. I have my API, and I've got a Blazor web app. Let's talk about the API first. Yeah. So I have 3 models. The first one is the course. It's all plain Poker classes. There's the enrollment, and there's the student, which makes up my 3 database tables. There's navigation properties on student and course for the enrollment class. And on the enrollment, again, there are navigation properties and an enum for grade. And I have my DB context here with some seeding going on. And of course, I have registered that in my startup. That's basic entity core, EF core for you. I have also got repositories for CIUD, and I have registered them too in my startup. Now, these are good, but GraphQL cannot understand it out of the box. So we need to make these types which are understandable to GraphQL. And for that, you start creating types. And in GraphQL.NET, to create a type, you inherit a class from object graph type. This makes it clear that this is supposed to be a GraphQL object type. And then you pass in the base class. And in the constructor, I can create fields for each of the properties in my base model, which I want to make available through my GraphQL API service. So if I don't want email address to be available by GraphQL, again, I can do that. That's by all means possible. If I want to bring in first name and last name as a new field completely called full name, that is again possible. If I don't like the name of the field that is in my base class, I can override it. So in this case, usually when you mark the student class as the base class of the object type, the fields take the name of the properties itself, but I can always override it using the name method here, extension method. And you can also provide a description for each of the fields. All these gets pulled into to the self-documenting feature. And I think I've got an example of deprecation somewhere. Yeah, if you want to mark a field as deprecated for some reason, you can do so by marking it as deprecated and giving a field a reason for deprecation. Um, I have an enrollment class here again, which inherits from object graph type. I just wanted to show you the enums. So if you want to create an enum, all you have to do is inherit a class from enumeration graph type, passing in the base enum, and in the constructor, I give a name and description. So that's all my object types set up. That's all inheriting from the object graph type and the base model. So that is the object types. Now let us start looking at the schema. So the schema is again a class which inherits from the schema in GraphQL.net. And in the constructor, I can provide my operation types, that is query, mutation, and subscription. We'll deal with each of that separately. But now let's have a look at the startup class to see what is getting wired up. So the first thing to do is register the schema, giving it the schema class. Then you can register GraphQL using the add GraphQL method. And I've enabled metrics if you want to see logging and more debugging information. This helps there. Then you can register your graph types. So when it comes to the API service, obviously we have our object types. We'll also have mutations, and for that we'll have input types, and we'll have types of subscription as well. So we don't want to be registering each of those types one by one. So we can use this add graph types. And what it does is it scans the assembly for all the objects, which implements the iGraph type interface, and then registers all of them for you. And I need to register my JSON package and the error info provider for detailed error messaging. We'll come back to this later on. I'm enabling course, and in my middleware, I'm using course. Again, this is something for later. And we'll set up the HTTP middleware for GraphQL. So this is the simplest way you can do that. This also provides me with an endpoint that is /GraphQL, which again you can override. I'm sticking to the bare minimum here because I don't want to get into the trouble of having a controller and then receiving the request there and serializing it, all of that. No, I'm making use of bare minimum here. And then I can set up the middleware for my IDEs using the use GraphQL graphical or the playground or the Altair method. So that is all the wiring up done for you. Now going to have a look at the API itself. So this is how the playground IDE looks like. It's actually my personal favorite. And this is Graphql. I believe Graphql was the first playground to come out, and GraphQL Playground is actually based on Graphql. Both of them does effectively the same thing, but I think somehow this kind of appeals to me. And this is the docs that I've been talking about. So if you remember the student type that I showed you, it is getting all those fields. And for each of the fields, it is getting the description that we did. So as and when you make your API more descriptive, this feature completely documents itself for you. So I can drill down each of these operations which I've set up and see more details, understand what it is returning, etc., which is quite helpful. And you can also see the schema definition language here. So there are clients like Strawberry Shake, for example, the client works with having the schema downloaded. So you can download the schema from here as an SDL file if you want. Again, there is support for passing in variables as a separate dictionary or having auth tokens as well. And let's have a look at the introspective feature. So if you want to introspect the schema or have an understanding of what it is all about, you can start off by __ schema. And then you have to start specifying what you want from it. So I'm going for the types. And for each type, get me the name and the description. So if I play this, it should get me everything about this GraphQL implementation. This gives me all the built-in implementation as well as my object types as well, which you can see here. I haven't added a description or name to each of it, but you can actually make it really clear and really descriptive, which is super helpful. That's on the server side. On the client side, I have a Blazor WebAssembly-based app with these two packages, the GraphQL client and the serializer for system text JSON. And it's here, and I need a little bit of setup code here in the program CS. I need to create a GraphQL HTTP client, passing in the endpoint and passing an instance of my serializer. And I need to register my GraphQL client. After this, the GraphQL client will be available for me to inject in my Blazor components and use for querying data or mutating or inserting data. Back to my slides. Now let's start looking at each of the operation types and see how can they be fulfilled in an API and then consumed in an app. The first one is query. It's one of the operation types in GraphQL, and it's the top level entry point for read operations. So it's used for getting or fetching data. You ask for specific fields on specific objects, but using a post operation. While in REST, we read primarily using a get operation. It is post in GraphQL. You can make it get using caching, but let's go with the simplest method now, which is post. The keyword for query operation is query. It's not needed, but it is always considered a best practice to have the keyword in place. And what you get back from the query is a hierarchical JSON response. And queries are executed in parallel. So if you are sending 3 queries into the GraphQL API service, it runs in parallel and fetches you the result. So let's see how this is created and consumed now. So let's have a look at the schema. The starting point is the schema. I have my operation type here, and using the service provider, I'm getting a required service for the Contoso University query, which is my query operation type. It is kind of an anti-pattern in ASP.NET Core to use service provider, but this is how it is done in the GraphQL.NET docs, so I've just kept to that. So let's have a quick look at the query operation type. It is again a type which inherits from object graph type, which means that this is registered for you at startup. And if you see my constructor, I've got fields. As I said before, regardless of whether it's an object type or an operation type, it is made up of fields. I have 4 fields here, which makes up the 4 operations I can perform on a query, which is getting all courses, getting the detail about a given course by ID, similarly, getting all students and getting the details of a given student. We'll deal with the student for query and we'll go to course for mutation and subscription. So to get all students get a list of all students, I specify a field. And what gets returned is a list of student. It cannot be a C# list of the C#, the EF core model that I have, the entity object that I have. It needs to be the GraphQL type. So I'm sending back a list graph type, which is the C#, the GraphQL corresponding of the C# list. And I'm sending back a list of student type. This is the name of the operation or the field. And this is the description. And I'm giving it an address where to fetch it from. And in my case, I'm using the students repository, the get all method. And all it does is use the DB context to get a list of students. Now, if you want to get the details of a particular student, it is quite clear that we need some kind of identifier in place. So to help that out, GraphQL has got arguments. And you can add arguments to any field, and you can have any number of arguments. But the most important point to remember about arguments is that they get matched by name. So if you pass in values to the service for a list of arguments, they get matched by name. So the order is kind of irrelevant there. So in my example, I have an argument called ID with a description, and it is a non-nullable integer graph type. And again, I need to resolve it. So to resolve it, first I need to get the ID from the query context, which I am doing by using the get argument method on the context, which has got the context of the query. And I can get my ID and pass it on again to student repository method to get the details out. So let's quickly test this in the browser and see the result. It's already saved my results for me. So the first is the student list. So the keyword is query, and I give it an arbitrary name because this helps going ahead if you want to debug anything that's going wrong. This helps with that. Let's come to this a bit later. Delete it actually. I start off with the students operation because I want to get a list of students. And for each of those students, I want the ID, the first name, last name, email, and related information. So let's see this in action. Should get me the results. So as you can see, it gets me a list of students. Now there's something called aliasing in GraphQL, where you can give an arbitrary name to even the operation. And what happens is the JSON data gets adjusted to mirror the query. You can even alias a field if you want. Even that gets picked up. So that is about querying the list of students. Now, if you want to query a particular student, obviously it has an argument. So again, I start off with the query keyword, give it an arbitrary name, and specify a variable, declare a variable. This is how a variable is declared in GraphQL using the $sign. And I give it the type that it is supposed to be. This type should match the type of the argument for the query operation that is here. And it needs to be an int, and it needs to be a non-nullable int, the variable, otherwise it won't work. And then I can start off with the operation and assign the variable to the argument, and then ask for the fields that I need. And to pass the variable value, I use the query variables. It's passed in as a separate dictionary. So if I run this now, I should get the details asked for. So that is how I consume it on the browser IDE. Now let's see how it is done in Blazor. So what I have in my Blazor app is a students page with all the names of the students and some specific details. And I can click through and understand the details about each of the student and their enrollments. So let's first deal with this. This is a routed component. So in my Blazor app, I have this page called students. I have specified a route template, which means it's a routed template, and I'm injecting my GraphQL client. I'm keeping it really simple for the demo, but you can obviously split up the component into classes and do all sort of cleaning up that you need to do. We'll deal about this later on, but we start off with specifying the GraphQL query that I need to send to the API, which is very similar to what I showed you. I have a private variable for holding the data that comes back from the JSON from the API. And Blazor gives us access to 4 lifecycle events to control what is happening when and where, and to do things when it happens. So usually, when you want to initialize a component with data, it's done in the onInitialized async method. It's the second lifecycle event of a Blazor component, and it runs soon after the parameters has been set, and it's a good place to initialize your data. So in that method, I can create a GraphQL request object, which is the request that I make to the API, and the query property is set to the string, the query string that I have created here. And using the GraphQL client, I can use the send query async method to send the request or post the request to the endpoint. And what comes back is a GraphQL response object, which has got a data field in it. And that data field will be of this type, students list data. So if you're wondering what the students list data is, this data that you see inside the data field in the JSON is what gets sent back. And I can always deserialize it on my end and use the data property to get the value in the students. So this is literally a C# representation of that JSON data. And again, I can then check for nulls, loop through, and display the data, which is what you just showed. So in this page. Now, when I go into a particular student details, I want to load the details of the student. And it's quite clear that, again, we need some kind of argument there, for which I have a parameter, which is specified here. So let's see how that's being achieved. Again, I have a student details, a Blazor component. It's routed, but this time I have a route parameter specified in my template. So this is the way you specify route template, route parameter in the route template. That's in curly braces. I have also constrained it so that the ID is always of an integer type. So this is route parameter. To consume that in a Blazor component, you create a public property of the same name as the parameter, the route parameter, and adorn it using the parameter attribute. Again, I've got the string as before, which is exactly what I showed you in my browser testing earlier. I've got a variable to hold the data that comes back, but this time we are using a different lifecycle event. So Blazor being a single page application framework, components, the on initialized method, which I showed you in the previous page, only runs when the component is loaded for the first time. So when the initial load of this particular component happens, every time the parameter changes, the onInitialize method doesn't call again. When the parameter is set, it straight away, the control goes into the onParameter set async method. It skips the onInitialized after the initial load of the component. So we can't use that method to initialize or give the data out. So we need to use this onParameter set async, where I create my GraphQL request object and set the query. And variables are passed in as a separate dictionary. So I create a dictionary, and the dictionary key matches the variable I have here, and I give it the value because this is coming from the route parameter. And as before, I use the send query async method to send the query to the API service, get the data back, loop through, and display the information. So that is what is get shown in here for you. And if we go visit some other page for this particular student, the enrollment details and the student details are different. A word about reading related data. So in GraphQL, by all means, you can use the standard EF code methods for reading data, related data. For example, when you are asking for a student, show me which courses the student is enrolled for and the course details of that particular course. You can use EF core for that. But when you use that, what happens is, first, GraphQL makes a list of students it wants to send back. And for each of those students, it tries to reach out to the database and get the enrollment details from there. So that's quite inefficient because, again, we have the N+1 issue. To overcome this, GraphQL has a concept called data loader, which is a kind of in-memory cache. So with data loader, what happens is that when it forms a list of student IDs, the first time the enrollment detail for a student is asked for, it fetches all the enrollment at once. It checks whether there's a data loader object in memory. If not, it fetches all the enrollments at once for all the students and holds that in memory. So, and the next time when the student, when another student's enrollment is asked for, it is retrieved from the data loader, which is like a cache, rather than hitting the database. So let's quickly have a demo of that in the service as well. So in my API, sorry, that's not the one. In my student type, I'm trying to get this enrollments, and for each student, I'm trying to get the enrollment details. So we need to use data loader for this. And the first thing to do is to set up data loader or register data loader in the startup. And that's done by using add data loader and registering the data loader. Data loader is installed as a dependency when you install the packages. So that's done for you. All you need to do is register it. And then you can inject iDataLoader context accessor into your constructor, and then you can start using it. So data loader is used for batch operations, and what it holds is a lookup object, which has a key and a corresponding value. So in our demo, a student can have multiple enrollments. So we need a lookup object rather than a dictionary, because dictionary can have only one key and one value. It cannot hold multiple values against the same key. With data loader, there's a get or add collection batch loader method, which helps you batch load data from the database. And you need to give it a name. And this is like the name of the cache object, and give it a method where to fetch the data from. Again, it's a resolver. And what this method gets is an IEnumerable of student IDs, because it tries to fetch the details for all the students that it has worked out. And what happens inside is standard EF core. You loop through the enrollments and find out the details. And then I'm converting it to a lookup object rather than a dictionary, and having the key of a student ID, because as I said, we need multiple values against the same key. So a lookup object is probably better. And what this does is, the first time it tries to load the student details, it checks whether there is this particular object in cache. If not, it creates that data loader and stores the information in it. And for further calls about the enrollment details of a particular student, it uses the load async method to load the details, the enrollment details of a particular student. And the way it does is by using the source.id property. The source is the source object here, which is the student, and it uses the ID property, which is the key which we have specified for our lookup object. So this is the data loader, or the in-memory cache in GraphQL for you. The next operation type is mutation. It is the top level entry point for write operations. Again, happens over HTTP post, and the keyword is mutation. Unlike queries where you need not necessarily have an argument, mutation always has an argument, and it cannot be any argument. It is best to have an input type as an argument. You can have, so if you are sending in a student, you can have ID, name, email address as 3 different fields, but it is better to put that together as an object and send that in. So they are called input types. And what mutations return is a graph type. So if I'm creating a student using a student mutation query, you can send back the same student that you've created as the return graph type, which is what I have done in my demo. But unlike queries, mutations are executed in series. So if you send 2 mutations to the API, it gets executed one by one. So let's see how that is set up. We start off with the schema class again. I have my operation type specified here and the mutation specified. That's the class. The mutation is again a class which inherits from object graph type. So it's registered for you at the startup as long as it is put in there. I have injected all the repositories that I need. And I've got 2 fields, one to create a course and one to create a student. So if you want methods to insert fields to update or delete information, you can by all means create that. Every field has a return type. So if I'm creating a course, I'm returning that course as the return type. It has a name and a description. And of course, it has got an argument. And the argument in this case is a non-nullable course input type of the type course. So again, arguments are matched by name. And it has got a resolver, which gets the course from the context object, and then using a DB context method creates the course for me. We'll come back to this when we talk about subscriptions. But let's have a quick look at the course input type. So for mutations to work properly and to for GraphQL to understand that this is an input type, it needs to be a class which inherits from the input object graph type, passing in the base object, which is the course, which is the EF model entity object that I have. And in the constructor, I can give it a name and a description, which helps with the documentation, and I can set up fields. So I can set up the bare minimum fields that I want to get this working. So if only course ID and title are needed for setting up a course, by all means, I can just have that. For each field, I can have the nullability defined. So which means that this won't work without having a non-null ID and a title. And I can always give it a name and a subscription. So let's see this in action. First in the browser. As you can see, it's again picked it up from the documentation. So create course is an operation which returns or gives back a course type, and it accepts a course input. So we start off by a mutation, giving it a arbitrary name. I have my variable specified here, which is a non-nullable course input type. Then we start off with the operation, specifying an argument and the variable, and I'm asking for specific fields once the course is being created. So let me start off by something here. It's when you pass the input type into the API endpoint, what you give is a JSON object passed in as a separate dictionary as before. So I'm setting up this course here. This should work. So that's been set up. And to see how this is consumed in my Blazor app, I have this little page, little component here called add course. I should be able to add something here, course 2001, 1 credit, and it should give me a message when it is added. So let's see how this is getting fulfilled. So again, it's a routed component called add course. I've got the route template and I'm injecting my GraphQL client. And I'm using the edit form component in Blazor to help me have this form on. This is a built-in component in Blazor which helps us create forms. The edit form expects a model. And in this case, I've got a variable here, which is of a type add course model. And it's a very simple POCO again with ID, title, and credits. It's very similar to the MVC concept. And on valid submit, I am posting all this data to a method called add here, which does the work of sending the mutation to the API. And I've got these input components here, which are again Blazor components. Input number is a Blazor component on top of the input type number, and input type text is on top of input type text. And I'm using the bind attribute for data binding. So the bind attribute helps with two-way data binding because this Blazor is a SPA, it's a single page application framework. So as and when you change the value of the field, the underlying model gets updated, the fields get updated, so the model is always up to date. From there on, I have the private variable to hold the data that comes back. And I've got a string which specifies the mutation query that I'm sending into my API. And in my add event, I have specified the GraphQL request with the query set to the mutation query that I've specified here. And the variables is again passed as a dictionary with the course variable, which I have here, the value set to the course model that I have here. And I can send a mutation to the API using the send mutation async method. And as before, I get a GraphQL response with a data property, which is of type course details data, and I can do the needful from there. So have a little messaging going on and finally reset the form as well. So that's about mutations. Finally, subscriptions. Subscriptions are pushed updates from the server. So rather than client polling the server, it's the server pushing the updates to all the clients who choose to subscribe. So it's not necessary for the client to subscribe, but they can choose to. And it works usually over WebSockets. Again, happens over an HTTP post. And the keyword in this case is subscription. Unlike mutations and queries, subscriptions are stateful because it needs to have an understanding of what's been sent to which client and what is coming in and what has gone out, etc. To get subscriptions working, we need both a client and a server package. We need the subscriptions WebSockets on the server, and we have a client package as well for this. So let's see this in action. With GraphQL.NET Core, subscriptions can work using the IObservable interface. I'm not really thorough with that the system.reactive namespace, but I'll try to explain it to the best of my ability. The only reason I wanted this demo in is because it's quite hard to find a subscription demo, and I really wanted to get this working as well. So in the schema class, I have a subscription operation type with the subscription put in place. It again inherits from the object graph type, and the way you specify a field for a subscription is quite different. So in this example, what I'm trying to do is whenever a course is added, the server lets the clients know that a course has been added. So it is quite clear that there is something in between, or a person in between, which is doing the heavy lifting of a course has come in, so let me give that back to the subscription. So the subscription is only possible for or responsible for relaying that data back to the client. It still needs that person in between the mutation and the subscription to understand that something has come in and that something needs to be pushed back to the clients. So for the fields, I have a name and I have a type and I have a resolver as always. And the subscriber is what does the heavy lifting of getting that data back to the subscribed clients. And it relies on something called the course message service, which is a service that I've written here. So let's have a look at this class here. So what I have here is a object of replay subject type called message stream. I think what replay subject is an interface. It's an object. It's a cached object which inherits or implements both IObservable as well as IObserver interfaces. And the way I understand it is an object which can be observed, so someone can keep a watch on it, and it can be observed, and it is an observable as well. So it kinds of observes itself. So that's the kind of meaning I get from this. So whenever a course is added, the add course added message is called by the mutation. And what that method does is it creates an object of course added message type. It's a simple POCO with ID and title. And I set the values to the course ID and the title, which has been just created. And using the onNext method, the message stream gets the pushed message. So the message stream always gets the new message that's been added. And the subscriber in the subscription gets the newly pushed courses from the message stream because it's continuously keeping track of the get messages as an IObservable object. So the mutation adds and sends a message to the course messaging service, and the course messaging service sends the data back to the subscriber in the subscription, and the subscriber in the subscription relays that back to the client. However, to get this working, it's very important to have this class registered in the startup as a singleton because we only need one instance of it for the entire lifetime of the app. And finally, to make this all happen, in the mutation, when I add a course, I also call the course added message service and give it the course that's been newly added. To see this in action in the browser, we start off with the subscription, test subscription, and course added is the name of my subscription. And I want the title coming back every time a course is added. So if I click this now, it goes into the listening mode, and it is already remembering that a course has been added from my mutation. It goes into the listening mode. And the next time a course is created, say 2001 here, oops, it's already existing. That should pick it up here. So it constantly gets that data because of the message stream object, which is both an observable that which can be observed, and it observes itself and pushes that messaging back. Now let's see how this works in the Blazor app. So I've got this course page here where I've got a list of the courses. It's very similar to the students page setup. But what I'm expecting is whenever a course is added, an update shows here and this data gets refreshed. So for that, in my courses component, when I initialize the data, I also call the subscribe method. And in my subscribe method, I'm creating a subscription stream to the endpoint. And this is how you set up the subscription stream. And you get a subscription stream, which is an IO observable. And whenever a message is pushed from the server to the client, I can then check for the response that comes back. The response is a GraphQL response, which is a course details data, course list data type. And I can use the course, I can make use of the course, the title property on the course to get the name of the course that's been added. And then I need to refresh the data as well on the table. So I'm calling the load courses data method again. And at this point, because the component is already loaded and there is no real action taking place like a button click, which actually forces the component normally to load, I need to explicitly tell the component to reload so that that loaded data is visible again. So I'm using this method called state has changed so that the component reloads, goes through the life cycle of reloading the data as well. So let's quickly see this in action and see whether it can see the updates coming in. So I'm going to post something through this create course query here. So let's say 2010. So that's it. I'm getting the messages from the server, and I can also see that in action. So that's the three operation types. Now, some of the advanced things that you can do with GraphQL, which I haven't discussed today: pagination, filtering and sorting, authorization. This is something which GitHub uses as well. You can go with authorization and authentication and filter it down to the level of fields. Like you can authorize and authenticate on a field basis so that only authenticated users can actually even query a field. Caching is complex in GraphQL because GraphQL is a specification. And caching is more of an HTTP feature, but it is made possible using, or somewhat made possible using, automated persistent queries, where what you do is you cache a query into some kind of cache, like a Redis cache, and thereafter an SHA is used to retrieve the objects from the cache. But again, that's an advanced feature of GraphQL on HTTP. And one of the most common uses of GraphQL is like a microservice style architecture. So you can have multiple GraphQL endpoints, and you can collate all of that into a gateway like architecture and serve that using a single gateway. And where GraphQL wins for me is exact fetching. And because there's no overfetching or underfetching, it's just exact fetching, resulting in no loss of or no ignoring data or less data that's being transported across the network. Client is always in control over what they want. So because of that, we always have a loose coupling between the client and the server. Auto-generating API documentation, which is fantastic. It's version free, and the ability to lock down fields by permission. As I said, you can authenticate against fields. Caching is complex. That's where it's one of the downsides with GraphQL. It can get really complex. File uploading can get quite wiry. You can encode the file and upload it, but again, the payload can get quite heavy in that instance. We've already seen nested queries and how you can get related data out of GraphQL API. But if you're not careful, you can end up bringing the entire database out with a single query, which can be really, really bad for performance. And of course, there's a very steep learning curve with GraphQL. It's a totally different shift from REST, in my opinion. So I have collated some of the some of the notes that I could find around GraphQL, not only about GraphQL.net, but also about Hot Chocolate and some videos and tutorials into this little page that I've put together. So feel free to have a look. And thank you again, finally, for having me. I hope you have learned and you have got something to take away from my talk today. Let me see if I have some questions.
Perfect. Yeah, thanks, Poornima. That was really good. I mean, I say that as someone who doesn't understand anything, but I still enjoyed myself. But yeah, I think we'll have a couple of questions coming in. And also, I can see a couple of people saying, can we have the slides? If you could supply us with the slides, that would be great.
Yeah,
but also,
absolutely.
we have recorded the whole thing, so we will be sending that out. It will probably be the middle of next week. So if you did miss anything, you'll be able to watch it again and again and again. So yeah, any questions for Poornima? We'll pop through those. And then we've got Clare Sudbery from MadeTech joining us. So yeah, I think there might be one or two in the box if you want to have a look, Poornima.
Yeah, sure. Slides, I can always give you the slides. I'll put it up on that bit.ly link, which I just shared. I'll tweet that link as well.
Excellent.
So how do you secure the data, which is the database? That is entirely up to the person who sets up the database. As I said, GraphQL is absolutely not concerned about where you store your data. So the integrity of the data is totally up to you. GraphQL is an application layer. It only concerns itself about getting that data out in that particular shape and format to you. Thank you. I know, Toby, thank you so much. Yes, it is a jam-packed session. It's a 1-hour session. Yes, I hope you can take away some of it and work through it in your free time. This is not something I do at work actively. GraphQL seems to be gaining traction these days because of Xamarin and Blazor. And that's the reason why I wanted to pick it up. So yeah, I think that's me for the day. Thank you so much once again.
Perfect. Just a last quick question there, I think, from Robin, if that's all right. What situations is GraphQL not good for? When should you avoid it?
Okay, that's a good question. In fact, GraphQL, from what I understand, is best used for medium-sized database because there could be points at which it can get really non-performant, as I said, with the nesting of queries. So what I have generally read about GraphQL is that it is best suited for medium-sized database, not like the enterprise level. Yes, we have GraphQL on Facebook, but Facebook uses GraphQL only internally. That was knowledge to me. So what they do is they heavily make use of the automated persisted queries in their system. But when saying that Facebook is one of the enterprises which uses GraphQL, Netflix uses GraphQL. So there are big names which uses GraphQL. Again, make a choice of when you want to use GraphQL, depending upon the situation, because GraphQL, it's a totally different kind of API if you want to read data in that fluid manner. When the client needs control of the API, client needs control over the presentation, that is one of the best choices for GraphQL. Xamarin mobile apps is one of the best choices. But again, from my general consensus, what I've read is that medium-sized databases are the best use cases for GraphQL. The bit.ly URL here, of course, I can give you that.
Perfect. And let's move on then. Thank you very much, Poornima. That was great. And next up is Clare Sudbery, Queen of Questions and Lead Engineer at MadeTech. I think you can share your screen when you're ready, Clare. I think I've made you a co-host.
Okay, fantastic. Just give me a minute. And while I'm fiddling about getting my slides ready, let me just say what I always say now when I'm doing remote talks, which is because I can't see your faces or get feedback from you in the same way as I would if we were in person, it's really helpful to me if people give feedback in the chat while I'm speaking. So feel free to chat or smile or say hooray.
Perfect. And then at the end, I'm assuming we can do a couple of questions with you as well.
Absolutely. Yes.
Perfect.
Of course. Yes.
Perfect.
Right.
Perfect.
Okay. So I think I'm ready to share my screen now. Just arranging everything on my screen. So find the big share screen button. There it is. And I want to share that. Okay, so hopefully you can now see my top slide, which is how to stop testing and break your code base.
Yeah, good to go.
Is indeed the title of the talk. So my name is Claire and I'm a bad person. I'm a bad person by my own definition because I wrote a bunch of code without writing any tests. And for me, that is a bad thing to do. So I prefer to use test-driven development, and I know that not everybody does. So part of this talk is to making the case for why I think test-driven development works. And this is about a code base that I wrote without writing tests first, and in some cases without writing tests at all, and the pain that it caused me. And what it did for me is it really helped me to recognize the benefit of writing tests and writing tests first before writing code. So the particular code base that I'm going to be talking about was not actually a .NET code base, but it doesn't matter because I'm not going to be talking about the code itself really very much at all, or only in very, very broad terms. This was actually a mobile app and it was written in Swift. Which is very similar to C#. In fact, at one point, I did originally start writing it in C# using Xamarin. But I ended up writing a little utility that would convert C# code into Swift. That's how similar they are. It is possible. But anyway, this was a mobile app written for iOS, and it was called SquareFill. And you can see a little picture of it there on the right. It's a very simple little app. All that happens is you are given a square full of shapes, or actually not full of shapes. Initially, all of the shapes are below the square, below the grid, and you have to drag the shapes into the grid to make a rainbow pattern. So it's very simple, a little bit Tetrisy, not quite the same as Tetris. It's the kind of app that I like to play. My phone is absolutely full of little puzzle apps that involve moving shapes around on a screen. There's something about moving shapes around on a screen that really gets the endorphins flowing for me. And also without being against the clock. I don't like it when it's against the clock. I just get stressed out. I just want to move shapes around on a screen. So that's how this game works. And it was a lot of fun. And the thing about it is, though, that the game for me was not just to play the game. Oops, sorry, went in the wrong direction. The game was not just to play the game. The game also was to make the game better and to make the code better. So as well as it being just that I wanted to have a game to play, I also wanted to improve the game, and I also wanted to improve the code. And as well as the reason I wanted to improve the game was because the problem was that initially the game was a bit too easy. I mean, it didn't take me long at all to master the game. And then I wanted the game to be harder. I wanted more challenges. I wanted more features. So I was the user. I was the product owner. I was the stakeholder. I was making the game for myself. But I also cared about the code being a decent code. I was interested in learning how to code in Swift and for iOS. So all of these things were all happening at once. I'm trying to write decent code. I'm trying to write a game. I'm trying to add more features to the game. And I'd keep up with that constant desire to improve the game. And the thing that fell by the wayside as a result was the tests. Yeah, no tests. Up yours, I don't need no tests. This is my son, by the way. You'll notice my son's appearing in a few of these slides. This is Felix. He's actually 19 today. I think he was about 17 when that was made. But actually, when you don't write tests, it causes trouble. This is my other son. This is Oscar. He was about 11, I think. It was this little video was taken on the same day. So the thing about not having tests is it can cause a whole load of pain. So my excuse for not having tests was that this little app that I was making was not my job. It was a hobby. I was writing the code in the evenings, at the weekends. Oh, thank you for the person who said happy birthday. Thank you, Ryan. Yeah, I was doing this in my spare time. I was doing it late at night. I was doing it when I was tired. I was always in a rush. I was always trying to get the next feature done. I never had any time. And so it seemed like if I just wrote the code and didn't write any tests, that would be quicker and I would save time that way. And initially, it did mean that I moved faster, but very quickly, it meant that I ground to a halt and was significantly slower. So this is what I learned through practice, and it really highlighted to me all of the reasons why having tests is a good idea. So I've grouped it broadly into 4 areas. So I'm going to talk about refactoring, I'm going to talk about encapsulation, I'm going to talk about spikes, and I'm going to talk about design. So the first thing that I'm going to talk about, and these are all areas which are helped by test-driven development and don't go so well without it. So the first one is refactoring. And the example that I'm going to give is to do with pixels and coordinates. So in the code, I wasn't always using the same way of referring to different areas of the screen. Sometimes I was using pixels in order to get a coordinate system. So for instance, on the second point on that slide, you'll see that arrow might have been pointing at 0, 6, because that's counting the squares on the screen in terms of the squares that my pieces are made up of. Or sometimes I was referring to it as 0, 1, 9, 2, which is using the pixels for reference. And I was switching between the two in different contexts. And initially that made sense, but the two different systems started to get all mixed up and confused with one another. And it got to the point where I could not tell, reading my own code, whether I was referring to pixels or squares. And it became extremely difficult to fix bugs. It became hard to read the code. But the worst thing was I couldn't easily refactor the code because I didn't have tests in place. Now, normally when I'm refactoring, and what I really want to do was just sort this out, tidy the code base up, make it very clear which coordinate system I was using, use the appropriate ones in the appropriate context. There were lots of clever things I could do. For instance, I could use a strategy pattern to behave differently depending on whether I was using a pixel coordinate system or a square coordinate system. But in order to make that work, I had to rewrite the code. Refactoring code is actually quite easy and very satisfying when the functionality that you're rewriting is covered by tests. Because what you can do is you can say, I need the code to function in this way. I'm going to say in my test that in this scenario, I expect this to happen. And given these inputs, I expect these outputs. Then I can refactor the code and keep running the tests constantly. I can refactor in really small steps. In fact, there's a whole video of me refactoring using that technique on YouTube. If you Google me, you should be able to find it. So normally, ideally, when I'm refactoring, I will refactor in very small steps and I will keep running the tests constantly. Every time I even make a really small change, like just a couple of lines of code, I'll rerun the tests. Is the code still working? Is it still functioning as it should? And then I can confidently refactor and know that everything is still working. I can't do that if I don't have tests. And in this case, I really wanted to refactor, but I couldn't be sure I hadn't broken everything while I was refactoring. And what I really wanted to do was write the tests, but the tests were really painful to write and debug because of this confusion over different coordinate systems. So I couldn't write the tests. I wanted to write the tests so that I could refactor the code, but I couldn't write the tests because of there was so much pain around pixels, and I couldn't refactor because I didn't have tests. So that became a significant problem. And tests make refactoring so much easier. The pixels were getting in the way. That's Oscar again, trying to do some clever stuff on the trampolines, but he can't because this small child is getting in the way. The way that I was handling pixels was getting in the way, and it was very difficult for me to fix. So the next example I'm going to talk about is encapsulation. And what I mean by encapsulation is where you can divide your code into small modular chunks that have their own self-contained identity. I really like this quote from Martin Fowler where he says, the essence of encapsulation is turning a design decision into a secret. So what he says is that modules should be arranged around system secrets, each module hiding its secret from the other modules. Then if the secret thing changes, you avoid a ripple effect. And what he means by secrets is details of implementation that your clients should not know or care about. Your clients, the clients of your code, which could easily just be other bits of code, they just want to know what your code does. What are the inputs? What are the outputs? How is it supposed to behave? And the great thing about tests is that they can easily document that. They can say, given these inputs, I expect these outputs. In this circumstance, I expect this behavior. You don't need to know why or how. You just need to know that this is what is supposed to happen. And if anybody breaks it, these tests will start to fail. So there you go, right off the bat. That's one really good advantage of tests, is that they allow you to test your encapsulation, and they allow you to document your encapsulation, and they often allow you to identify the boundaries where the encapsulation should take place, because your tests can say, okay, I expect this behavior in this context. Oh, right, okay, so I can see that this is a boundary and this is something that I can encapsulate. Another problem that I came across was an over-reliance on acceptance tests. So let's say you've managed to create a modular system, your secrets are encapsulated inside a particular module, and that module might be a class, it might be a set of classes, but a way of grouping your code. But the secrets inside the modules do need to be tested. And another way of thinking about this is that you don't want those modules to be too large. You don't want them to have too many responsibilities. And this was another problem that I encountered, because what I did was, I mean, I was very aware of the fact that I wasn't writing tests and I didn't feel great about it. And at one point I decided, it's okay, what I'm going to do is I'm just going to write acceptance tests. So I'm going to write tests at the very edges of my system that just very broadly describe how the system should behave. And as long as they're passing, they're going to be great documentation. They're going to say that, you know, if you're at this stage in a game and this thing happens, then this should be the outcome. Those were the kind of things that my tests were saying. And they were just acceptance tests. But the problem was that because they were testing the system only at its very edges, one test would be testing several classes, several implementation details, several functions. And when those tests failed, debugging them became a total nightmare, because what you're doing is you might be defining a module, but you're defining a very large module. And it means that within your code, there might be a complete mess behind that. You've defined the interface at the very outer edges, but inside that, because you haven't defined any tests at a smaller, more granular level, your code could easily not be very well encapsulated at all. And your tests aren't helping you to determine that. So one of the things that I learned was that only having acceptance tests and not having unit tests, not terribly helpful, because I had to debug too many things at once. So one of the things that you might notice when you're trying to keep your code well encapsulated, one of the things that you'll often be doing is you'll be making decisions about what's public and what's private. So the public methods on your class will be defining the outer interface, how the class is viewed by the rest of the world. And then some of the functionality is going to be private, it's implementation detail. And it might only ever be tested via the outer interface. So you might have an outer method that allows you to find out the position of a piece on a screen, and an inner method that's fiddling about with coordinates that really nobody needs to see, because it's just one layer in, and because the outer method is being tested in a unit test, the private method doesn't need to be tested. It is being tested, it's being tested via the outer method, the public method. But then you might decide, actually, what can often happen in that scenario is that you see that your private methods are beginning to proliferate, and actually they contain quite a lot of logic and functionality that you'd like to be able to test at a more granular level. And something that often causes people headaches in this scenario is they think, but I really don't want this method to be public, but the only way I can test it is by making it public. And then you find people making methods public purely for the sake of testing, which is a bit of a smell. It's not a great practice, because you think if it's private, then it should stay private. But then people, you know, get in a bit of a mess around this. And I really like this quote, which I think also came from Martin Fowler. It's better to break encapsulation principles to get tests in place than it is to break testing principles to keep encapsulation in place. So what people will often do is they'll say, well, I'm just not going to test that small granular bit of logic because it's in a private method, and I don't want to make that private method public. So I'm only going to test it via an outer method, which has the similar problem of what I was talking about before of only using acceptance tests, because it means that when things break, there's an awful lot of debugging that has to happen, and it's a lot harder to pinpoint exactly where the problem is. And in this scenario, what I would normally do is I would extract out the functionality that's beginning to bloat the original class into a new class that has its own interface and has its own public methods, which are being called by the other class. But in order to get to that point and work out what needs to be public and what needs to be private, and where the class boundary lies, I'll quite often make methods public purely for the sake of the test. And then once I've worked it all out, then I'll get myself back on the footing that I wanted to be as far as encapsulation is concerned. And the key lesson here is that you need to be able to test your code. That's the thing that's really, really useful. Another thing that I really like, a nice little message, is this one of don't wait for the racetrack to test the car. And it's another argument for writing unit tests and not only relying on acceptance tests. And the point of this is, what we're saying is, I don't need to have a full production environment and a full and an actual released product in order to be able to test various elements of it. So what I love about unit tests is the fact that you can write one very small function, but maybe with some complex logic in it, and be thinking, I think that's going to do what it should do, but I'm not entirely sure. And if you don't have unit tests in place, you can often find yourself, and this is what I used to do in the olden days before I'd even learned about tests, was I would write a piece of code and then run it, and and then be a user and interact with it, and then see, okay, does this thing do the thing that I want it to do? And in the case of this particular app that I was writing, just moving pieces around on a screen and understanding what the pixels are doing, you could have to devise quite a complex scenario just to see if one tiny little bit of logic was working the way you expected it to work. And that could be quite slow as well, particularly if you're writing a mobile app. You have to spin it up and you have to run it. There's a little kind of, it runs on a computer, and there's kind of a simulation. You don't have to deploy it to a phone, but still it's not quick. And you can take, you can have to wait quite a long time, and then you have to move the pieces around on the screen to get the exact effect that you're looking for in order to test just a couple of lines of code. Whereas unit tests can run in milliseconds. You can write the test, write the code, run the test. Does it do what I thought it was going to do? Yes, boom, done. So much quicker. So I don't want to have to run the code every time I'm going to test the car, which is the racetrack analogy. And this is one of the many things about people think that writing tests is slow. It's not, it's fast, because it gives you that fast feedback. So yes, it takes slightly longer to write code and test than it does to just write code, but it's so much quicker to test the code and find out whether it's working. You can do it in milliseconds. The other thing that I like to do is I use Ncrunch when I'm working in .NET. And there are various other similar tools for different languages. And what Encrunch does for me is it runs all the tests constantly in the background. So I don't even have to run the tests. I can change a line of code and it will detect which tests are impacted by that line of code, and will rerun those tests and it will go red instantly if I've broken something. And that's fast feedback. That's fast. That allows you to detect problems fast. That is quicker than waiting until you've written the code and then testing it, and not maybe and maybe waiting until some edge case before you recognize that there's a problem that you hadn't anticipated. So not writing tests is a false economy, and not running your existing tests when you change the code is also a false economy. So when I mentioned Encrunch, the other thing that can happen, even if you do have a good test suite, and even if you're doing test-driven development, you can make a change to a piece of code and then make another change and then make another change, and not recognize that you just broke a bunch of things elsewhere in the code because you didn't run the tests. And you could have done. If you'd have run the tests, you would have worked out that that change you just made might have made your current test pass, but has made a bunch of other tests fail. So ideally, you want to run the whole test suite every time you make changes. And there's a whole other talk about how to design a good test suite to make sure that it's not slow. But having something like Encrunch means that you can just have those tests running in the background, because otherwise it is really important to remember to keep running the tests. Another false economy is not doing that. And there's been several times when I've made several changes and then run all the tests and found that those of them are failing, and then had to go back and back and back to, oh, which one of these changes was it that I just made that caused these tests to fail? Whereas if I'd run them on every single change, I would have known instantly what it was that had caused the failure. And another thing that's worth talking about actually is that if you have been bad and haven't been writing tests and you're retrofitting them, sometimes you might accept in the interim period that you're just going to have to write tests as problems arise. So I have to confess, there was another project that I worked on around the same time. I was being banned in 2 different projects at once, that also I wasn't writing the tests as I was going. And what happened was, and what I did then in that case was, as I found bugs, I wrote tests for the bugs. So every single bug got a test as I fixed it. And that's one way of gradually catching yourself up if you don't have a good test suite. But the best way is to write the tests always before you even write the code. So another example that I wanted to talk about was the danger of spikes. And all I'm going to say there is that some people often say, oh, well, this is just a spike. And for those that don't know, people use the term spike to say, I'm just experimenting. I'm just testing. What happens if I do this? I'm using a new piece of technology, or I'm trying out a new technique. And because it's a spike, it's just an experiment. It's not production code, so it doesn't need tests. And the problem with that is that spikes very often end up becoming production code, and suddenly they don't have tests. So I would always advise writing tests even for spikes. There are exceptions. So the obvious exception is if you're learning a new technology and you haven't managed to yet work out what your integration path is going to be, or how everything's going to hook up, and there's some areas you haven't worked out how you're going to test it yet. But in most cases, I would advise writing tests in spikes. The last example I'm going to talk about is design. That tests can help you with design. So this is one of my many diagrams that I had. This is about what happens if a piece goes down a corridor. And what about if it comes down a corridor from above? Or what about if it hits a piece on the left? Because you have to detect obstacles. That's the thing. My code detects obstacles. What about if the obstacle is on the left? What about if the piece is going around a corner? There are lots of different ways in which you might detect obstacles. And what I found was that because I wrote tests, that really focused me on what those different scenarios were. What are these edge cases? I drew the diagrams to help me write the tests, to help me identify scenarios. And that then helped me design the code. So the blurb for this talk talked about how I got myself in this sticky situation. I was designing this app, I hadn't been writing tests, and I realized that one of my big problems was that nobody could see what I was doing. Nobody knew I wasn't writing tests, so I wasn't embarrassed about it. But it doesn't matter. It wasn't about being embarrassed. It meant that I was writing rubbish code that I couldn't refactor, and it was getting harder and harder to add new features because I didn't have tests and I couldn't refactor, and I was in this horrible feedback, this kind of vicious cycle. So I invited my friend Sal Freudenberg to start pairing with me. So this is also a plug for pairing, because we could keep each other honest. We could share, we could communicate. I could say to her, oh, I don't want to write a test. And she would say, yes, you do. You know you do. We'd go, okay, I do. Okay, let's write a test. And here, this is really nice. This is my older son steadying my younger son. This is him being a helpful pair. So, advice and conclusions. All of the rules that exist around test-driven development, all of the bits of advice that you'll hear, they all exist to make your code better and your life easier and more pleasant. They haven't been created as sticks to beat you with. They're not supposed to make your life harder. They're supposed to make your life easier. And like, for instance, people have opinions about whether you should go outside in or inside out, i.e. you should start with the acceptance test and then move, kind of hone in on the unit tests, or start on the inside with the unit tests and move out. I'm not going to tell you that one or the other is right. Sometimes you have to mix and match because of practicalities, or just because that's the way your brain works. That's okay. But be aware that people have opinions about things. Don't reject them outright. Try them out. Think about it and think, well, why am I doing it this way? And what if I did it another way? Keep an open mind. Because I rejected a lot of rules. It's, I'll just have acceptance tests, it's fine. And then I learned by experience that, okay, no, it's not, I'm not going to get away with this. And that allowed me to understand even better why people recommend doing things in a particular way, and meant that I was free and unfettered to do my best work, as you can see my son doing when there aren't toddlers in his way. So, summary. No tests is a false economy. Not running the tests every time you make a change is a false economy. If you have tests, it's much easier to refactor. If you need tests before you refactor. Acceptance tests on their own are not enough. You can write new tests in response to new problems. Keeping everything green is a really good idea. So again, like I said, there is another video of me demonstrating a refactor where I'm making tiny changes, and every single change that I make, I'm running the tests. So what I'm not allowing myself to do is pull a class apart and make my code unrunnable for a significant amount of time before I put it back together. And because if you can't run the code, you can't run the tests. So making tiny changes, running the tests, keeping them green. If anything goes red, fix the problem first before you continue. So keep running those tests and keep them green. Pairing keeps you honest, and it says 3 more slides there because otherwise I forget that. First of all, there's this rather fantastic video. Again, that's my son on the left. This is how great it feels when you write good tests. And then the next slide that I wanted to remember is that we have recently launched a podcast at Made Tech, where I work, and it's a podcast that I host, and I would highly recommend it, obviously because I host it, but it's called Making Tech Better. It's available on all the podcast platforms. We so far have interviewed Jessica Kerr on semathecy, Paula Paul on transformation, John Skeet on coding for fun, Kit Collingwood on tech for the common good, Dave Rogers on toxic technology, and I Know Corey on retrospectives anti-patterns. That was the episode that was published last week. Coming up, we've got Esther Derby on people and patterns, Kevlin Henney on balancing change, Anne-Maria Maffedon, who's the CEO of STEMETS, on women in technology taking control, and Mary Williams on bringing change to legacy tech. And the final plug is that we are recruiting at Made Tech. You can go to madetech.com/careers to find out more about that. Thank you very much.
Perfect. Thank you very much, Claire. I just checked in the box to see if we've got any questions. There we go. A few comments. A few fans of NCrunch. I don't think any questions. Has anyone got any questions? You can feel free to unmute or pop them in the chat box, whichever you prefer. A deafening silence ensues, which means that you've answered all of their questions. Cool, perfect. Well, in that case, if no one's got any sort of questions or anything to say, we will wrap it up there. And a huge thank to Poornima, who's left now, and also to Claire. Thank you very much for your time. The video recording we will send out probably the middle of next week. I will also send out the link from Poornima with all the GraphQL info in, and Claire, I'll send out a link to your podcast as well, or some info surrounding that. So do keep a lookout. In terms of our next event, we have one on June the 15th with David Fowler, who is the partner software architect at Microsoft, the creator of Signal R and ASP.NET Core. So a really cool talk coming up next month. And then we will have a few more in the pipeline for the rest of the year. And I think that pretty much concludes it for tonight. So thank you everyone for coming. Keep an eye out for more emails and events and announcements, and we will see you all very soon again.